Obviously, the EFAS 4 has been calibrated. The job then is to also evaluate the results to try and help you as forecasters make best use of the system, understand its performance. And so we have two evaluation kind of categories. The first is actual hydrological model performance itself. So this is evaluating the 6 hourly hydrological model based on the long-term run and available observations. So this is performed at the 1,137 observation stations from 1990 to 2017 with at least 4 years of data. Using a similar metric as with the calibration, we're using the modified Klein-Gupta efficiency score, which is now very common in hydrology. And one of the key advantages is that this summary metric can be decomposed into 3 components, which are the Pearson correlation that records timing errors. We have the bias ratio for looking at systematic positive and negative biases, as well as the variability ratio to understand if the model is capturing the variability within the observations. And we can see in the diagram to the right, these are the kind of new plots we have available. We call them the KG speedometer plots. And I think these quite nicely summarizes for individual stations kind of the summary KG, which category it fits into. So 1 being, the model is absolutely perfect against observations, which of course we know is not possible. But the blue values will be very, very high hydrological performance skill, right down to the lighter blue and grey, which is worse. And the advantage of these plots is we have the decomposition. So even if we have a KG value that's perhaps quite low, maybe in the category of 0.2 to 0.4, it will be useful, as you know, as forecasters to understand, well, perhaps if the correlation remains high, this station and the simulation of this station could actually still be useful for EFAS, because we're using a relative threshold, we're using model thresholds in forecast mode, so therefore a systematic bias may not be as big of an issue, but still we want to show all 3 components. And so the model is performed then against 6 hourly time steps for the available observations that we have 6 hourly data, so the 406 stations. But when we only have daily data available, we aggregate the 6-hour model up to daily and we compare them with that, so for the rest of the 731. So the full details on the methods on the hydrological model performance is on the CHEMS wiki pages, the documentation, which we'll mention later on what these are, but these are really an area we want the users and users as forecasters to be able to look at more detail on the methods and the results and stuff. So now we want to look at the medium range forecast skill as a priority. And before, from the bulletins, you will know we use the continuous ranked probability score quite often, but what we have been missing in previous years has been a long-term and large sample reforecast to really understand the skill of the system, rather than just season to season. So what we've done is we've performed long-term reforecasts. I'll discuss that shortly, but just to introduce the new headline score that's now available on the web is the maximum lead time in days in which, so out to the medium range, in which the continuous ranked probability skill score, the CRPSS, is greater than a value of 0.5. And that's compared to a persistence benchmark. So the full detail on how we arrive at that score and the reforecast, again, can be found in the detailed documentation. But just a summary for those who would like to know, we're using the ECNWF ensemble reforecasts that are run on an on-the-fly procedure, so twice per week in real time. That when the operational model runs the 51 members that we're used to seeing, the meteorological data for EFAS, we also run a long-term reforecast for a reduced number of ensembles, so 11 members. So on Mondays and Thursdays, the supercomputer will run these for 20 years in the past, and what we actually use that information then to run through the hydrology. So we have essentially 20 years from 1999 to 2018 at a 6-hourly resolution for every river pixel on the EFAS domain, and so essentially running EFAS for the last 20 years almost. and we take all that data and we then perform our skill evaluation. In this instance, we're using our benchmark forecast, so we're comparing if EFAS 6 hourly is better against a simple persistence, and that's evaluated against proxy observations using the force simulation, so the EFAS long-term run. And we have this currently on the web interface for 2,651 fixed reporting points, and so these just give forecasters access and to look at the information in more detail, but the actual raw data behind all that for every grid pixel is run and is available.